So my name is Koos de Beer. I work with the University of Pretoria. Started out as a student at the university, then transitioned to attempting to be an academic for about 17 years. And now I find myself being a recovering academic, where I work with various institutions within industry with regards to XR strategy, research and development solutions. So from the type of stuff that Luciana talked about, up to strategy and things around XR technology, specifically focusing on immersive teaching and learning. The reason me and my colleague we're talking together is so that we can augment one another when it comes to the work we do, because we work really closely together. So I'm just going to quickly discuss what is happening at the Faculty of Health Sciences, but it's closely linked with mining engineering. It's closely linked with the Faculty of Engineering, Built Environment, and IT, and it's also closely linked with theology and religion and architecture and everywhere, because everybody's looking to use immersive technology or XR technology in teaching. And I'm there to assist them, because working inside the system allowed me to understand the system, and now working on the outside of the system, it allows me to hopefully facilitate research, teaching, and all the aspects around that. So first of all, it's like I said, the Faculty of Health Sciences and the Faculty of Engineering, IT, and Built Environment. We're looking at implementing XR experiences, XR teaching, and sharing these experiences and collaborations between faculties and departments. We have various applications, which there is a link on my website, and my colleague, Mr. Maritz, will also share with you about the projects. We do a lot of things. I tend to identify the problem, and then if something exists, we'd rather use that than rebuilding it. If it's something that's not been built, we build a pilot, we deploy the pilot, we test it, we see if it actually works the way it does, and then we look at larger scale deployment. But the challenge with XR technology, as everybody should supposedly know, is that in the various disciplines, everybody's using, or some people are using XR. But when you look at the institution as a whole, in terms of teaching, in terms of the research aspects around that, it's mostly the technical departments that can do these things, because it's those people that have the capacity to build their own stuff. So what I have made my personal mission at the University of Pretoria, and hopefully outside as well, is to streamline this process and allow both students and staff to utilize this tool to teach with, to do research with, and to facilitate the research. I don't have to do research anymore. It's not part of my job, but I like helping people do the research, and I like contributing to the research itself. So just a quick overview of the various departments and faculties we work with, that I've worked with, is mining engineering, civil engineering, the Department of Taxation. Within Faculty of Health Sciences, it's anatomy, the Center for Simulation and Innovation, which is what they call the skills labs at the faculty. That includes both wet and dry labs. And I don't know about you, but when medical scientists say wet lab, it makes me uncomfortable. So this is just a quick summary of kind of the approach I'm taking to this. So I'm choosing not to focus on the tech side of it and the technology side of it, but rather on the strategy and approach to it, because the technology and the tech approach to it differs from implementation to implementation. It is something that you have to look at specifically, and broad-based solutions are available out there, but they're expensive and they're difficult to do. And in South African context, we always look at scalability and deployability when it comes to these type of solutions. We can't buy 100 or 150 or 200 headsets. We can't assume that internet connectivity is a thing that exists consistently and of high speed across the board. And even the concept of electricity is problematic. So if you look at the graph that I'm showing you there, I'm talking about this approach, and this approach is being spearheaded by the Faculty of Health Sciences, and we're collaborating with engineering and with mining engineering specifically. I'm talking about exposure to the technology, then how people engage with the technology, developing what I call XR literacy, and identifying ambassadors within the space. Then enabling researchers and students and lecturers to actually utilize this technology, and then providing them with a type of learning space or an environment where they can actually do these things, because this does not necessarily translate to traditional laboratories, even though I've seen in Leeds, for example, and in London, Imperial College London, where they do have labs where the headsets are linked to computers. So first of all, exposure. In the Faculty of Health Sciences, I had the privilege of assisting them in designing a space that we call the XR Toy Box, which is located within their library. It is an open space where we have various XR technology in there, and it's open for staff and students to come and play with the technology. It's not a learning space. It's not a lab. There's no formal learning happening in there. It is primarily to expose staff and students to the technology. Students develop this literacy to use the technology, and staff sees this and kind of starts to understand what the technology is capable of, and hopefully allow them to think of how it can be used within their context. Then the second part is the engagement, engaging both staff and students. So when you have a staff complement there's new and excited people about technology, and then there's the old school people who's not necessarily into the technology and willing to change the way they teach, having everyone on equal footing for the first time in a VR or an AR platform allows everybody to look at this from their context and kind of see where the use is it for this is. The importance for me from the student's perspective is this XR literacy that I refer to. This allows the students to understand how the technology functions. It's like using a computer, where when they actually encounter learning content within their studies, they're not overwhelmed with the technology, but rather have an understanding with the technology. And then they can engage with learning instead of spending the first half of the session understanding the technology and then engaging with the learning. This is something that we've seen since we've launched the Toy Box, and beforehand for the last, let's say 3 or 4 years, with people just engaging with XR technology for the first time. There is a learning curve involved, as everybody hopefully knows. The triggering in staff to start thinking about how the technology works, what they can do with it, and this exposure to the various types of technologies is also very important, because then we can start looking at how we can use it within their context and how we can start assisting solving their problems. And then the identification of ambassadors. I call them ambassadors. These are the drivers. These are the people that's excited about using the technology. These are the people that want to use the technology. And these are, I refer to them as the subject matter experts. It's the people I work with. And my colleague, Mr. Moretz, who's just after me, he's my SME and he's my ambassador in the Department of Mining Engineering. He's excited about the technology and how this technology can change how things work in the mining industry. Then enable, providing them with different types of technologies, either things that we build in-house as proof of concepts or things that we find on the outside, and assist them in deploying on a pilot basis and then larger deployment. Enabling staff to use and create their own immersive teaching content. We developed a platform that allows them to just film or take 360 images and then include it in a system where you can train people using a scenario, a branching narrative. This is very valuable for the Faculty of Health Sciences because most of their training, clinical training, consists of scenario type training. So this allows them to film a branching scenario on dummies, because these dummies are very expensive, so the students don't get a lot of time on these dummies, and then put it in VR so that the students can continuously engage with this without having to just have this one opportunity to engage with the dummy. So practicing things, making mistakes. That's actually another reason why the branching narrative allows you to show what happens when you make the wrong choice, which is rarely possible in the medical environment, in the real environment. And then the implementation in mining engineering, which is the in-video assessment, which allows them to identify components on the space itself. A lot more explanation about these tools are available on my website, and I'm sure my colleague will also cover some of them. But my role is then just to provide them with the expertise and with the how can these things be done, and if it can be done with what we currently have, or where it can go and what's possible. And that is why it is such a privilege to actually work with health sciences, mining engineering, architecture, because There's a lot of problems that are similar. There's a lot of problems that the one has solved, but the other ones are still struggling with. I love to say mining is really good with training in VR. Medicine is really good with production in VR, telemedicine and things like that. So swapping the expertise around there so that mining can start using VR in production and medicine can start using VR in training. And then the last part is learning spaces, setting up spaces that allows staff and students to actually use this in a learning context, in a teaching context, or a research context. These are things like dedicated computer labs, dedicated XR spaces, the concept of living labs. We're currently developing one at the Faculty of Health Sciences. You can see below there, there's a cylinder in the Department of Mining Engineering, which is just a 360, it's a cave. And using these as learning spaces for XR technology, where different departments and different faculties can actually use it to train their students in. That is me with 10 seconds over my time, I think. I think I had 10 minutes split with Mr. Maretz.